Yes, thank you. So my name is Skjetne. I work as a senior engineer at the Norwegian Public Roads Administration, and I'm responsible for the development of the Norwegian interchange node. I know we haven't explained that part yet, but that is the CITS broker that has been mentioned previously. And I'm responsible for the central CITS station for the Norwegian Public Roads Administration as well. So I'm going to start with a bit of how stuff looks from my perspective. So what we do have now, we have all the message definitions, and the use cases, and the standards in place for that. The short range stuff is up and running, and we have the security part on lock, though a lot of them are still using L0. That needs to improve over time, obviously. And then now we have the long range part. Mainly for now, it's based on proprietary protocols from OEMs and service providers, but I will show an example of one implementation for inspiration if you're curious later. But what's missing? So right now, the CITS IP-based interface profile that is specified by C-Roads is just a specification. In due time, hopefully that can change so we can get it into a standard as well. And also there might be some work that needs to be done on alignment of current specifications and profiles that we do have, maybe specifically the security profiles, in order to use them, in order for them to fit well with the IP-based systems. But I would like to say that these missing parts are not showstoppers. You can deploy this system now, and you can also do it for cheap. So, and I'm gonna show you a bit of how we did it at least. So let's look at some blocks. This is kind of the basic building blocks. Some details might change depending on your implementation, but you will find the same building blocks in virtually any deployment of this. So on the far left, you will have the data sources or the data consumers. This could be vehicles, for instance, for service providers or OEMs. Or it could be maybe contractors or traffic management centers if you are a road operator. And then in the blue box, you have the CITS station, which is responsible for creating and decoding messages. This could be OBUs or RUCs on the roadside or inside vehicles, or it could be a central CITS server, kind of like an RSU in a rack. That's the way we have done it. And then in the orange box, you have the PKI part, which for our case is tied to the European Certificate Trust List. And then you have the green box, which is the interchange or the CITS broker, which disseminates messages between different actors. And that could be operated nationally or regionally, or it could even be a commercial service. And it works fine either way, how you choose to set it up. And then if this interchange implements the improved interface, which we're gonna learn more about when Risto takes over, you will get access to all the data from the entire federated networks of these interchanges. If it only implements the BI, which we'll also hear more about later, you will need to connect to the interchange that covers your area of interest. So the different countries usually. And I've included this slide because some of you might be interested in how and who built the system for our specific implementation. So for the Norwegian interchange, we've contracted with a company called Bouvet, which build and operate our interchange. It is available as open source on GitHub for anyone who's interested in that. And it's still a work in progress. We're still working on it. Then the central CITS station that we operate has been built by Q-Free. It handles the CITS message creation, signing, decoding, and validation of messages. And our L0 root certificate is provided by Tesca Labs. And then in addition, you have some purple lines here, which represent the interfaces. And these have been built internally within the Norwegian Public Roads Administration, which also includes the client that sits between the interchange and the CITS station. doing the protocol conversions. This is basically the same figure as you saw on the previous slide. You might recognize the colors, but this shows kind of an example data flow where you want to distribute data from a robot operator down to vehicles. The last step down to the vehicle, the part without a box down here, would usually be handled over a proprietary protocol by the service provider or OEM. But here I'll show an example of how we've done it down to our own vehicles, our own fleet of Polestar service vehicles as inspiration, but it could be done in different ways. So information is coming either from our contractors or from our traffic management systems. Then it's fed up to the central CITS station where the messages are turned into CITS messages and signed with our certificates. And then they are published as denim messages onto the interchange. And then with anyone has a matching subscription, such as message type equals denim, they will get this message. The messages could be decoded and verified by the OEM's backend and then sent out to each vehicle using MQTT. The messages are published on a topic representing the geographical location of this message. And then you have the vehicles which can then subscribe to topics based on the vehicle's location, get all messages in its surrounding area. An alternative, of course, which was mentioned previously, is that you could take the CITS station and put it in the car in an OBU, and in which case the OEM or service provider's backend could just forward the CITS messages directly. It doesn't really matter how you choose to do this. And then finally, this is kind of the topic structure that we chose to do message distribution down to the vehicles. So you have a vehicle here in the middle. It subscribes to a 3x3 grid around the vehicle. And when the vehicle moves out of the central tile to, for instance, the tile on the right of it, the three leftmost tiles, the column on the left will then be unsubscribed to, and it will add a new set of 3 tiles to the right, which then means that the vehicle is again in the middle of a grid of 9 tiles. So it always has kind of a bubble around it where it can get data. And again, this is not part of any formal specification. Most OEMs and service providers already have their own way of doing this, but maybe C-Roads will publish some sort of reference or example implementation for this in the future. This is kind of the way we've done it. And most importantly, if you remember anything from this presentation, I hope that it's this slide. You can implement this right now. You can do it in a standardized and well-specified way. You can do it in a way that supports both long range and short range. You can do it for relatively cheap with almost infinite coverage without expensive physical infrastructure if you want to. But you can also keep the direct communication. It should work either way. And if you're building it this way, since it's all software, it's rather simple to iterate and improve upon over time as well. So there's no use in waiting. You can start building this stuff right now. So thank you very much.